Okay guys, gonna just test the bolts before I label them, so there's no use barcode labeling if they're slow discharge. So these batteries have been sitting for more than 2 weeks, probably more like 4 weeks to be honest. So these are the 16650 ZTs, Sanyos. I've had a lot of problems with these, but I'll check a couple out. And my method is, if they've all been charged up to 4.2 volts exactly, or 4.19, around that, and if they drop below 4.10, anything under that I will mark them as faulty. They'll be, consider those as slow discharge, especially most of mine usually about a month sitting around for, so yeah. Alright, just get the voltmeter, chuck in, so you can see that. Yep, you can see that. 4.14 good, 1.4 good, 1.4, 1.4, 1.6, 1.6, 1.6, 1.5, 1.5, 1.5, 1.6, 1.0. Ooh, it's close. But generally, if they are slow discharged, they won't come up with good capacity when I test the capacity on them, or milliohms maybe high. So we'll get back to that for 1.6, 1.7, 1.1, 1.6, 1.6, 1.7, 1.5, 7, 6, 7, 6, 7, 7, 6, 4, 6, 8. Ooh, that one's close. 7, 5, and 7. Yep, so they're all reasonably okay. So my next step is to barcode label them. Be right back. So these are my barcodes. Printed these on a little mini thermal printer. I'll show you that in another video later down the track. So they're just serialized numbers, and basically they'll just go in my database so I can know what they are. Right. Got this out of a what was it? I got this out of Makita drill, and it's perfect for holding batteries on top. You can just chuck it on there and they don't roll away on you. So if you find yourselves one of these, I'd keep them. They're pretty handy. So adding the barcodes are pretty boring and pretty simple. I always have the positive on the left when I make them, but that's just me being a little bit OCD, but that's okay. And I just roll it like that. And there we go. One barcoded battery. Lovely. Keep going, next one. See, I haven't actually removed this yet because they could still be faulty, and I don't want to spend hours removing gunk, and they could, you know, possibly be 37 milliamps or something, and some of these ones I've tested. So ones I know is going to be okay. I'll usually clean them up, but it's not worth wasting the extra time, especially if they're going to be faulty, going straight into the bin to be disposed of, recycled it a different way. And this is very exciting stuff right here. It's a little bit hard because I've got the camera in the way, so normally I do is a lot faster. But anyway, and it is an extra step. Like most people just test them and sort them, especially people building power walls. They have a nominal one. They only want something 2 amp hours or more or something like that. So I kind of like using good systems, and you can view the history of them and get data and filter data and find out which batteries are good and which ones are going to be pretty shit. Those ones got too much gunk on them, so I'll clean those up and put a barcode on a bit later. I just don't want to put the barcode over the sticky stuff. It'll just be lumpy and ugly. Yeah, oh well. Mind you, most of these ones I tested have been not so good, so I'm not too worried about these particular ones. I think the best one I've got is 1700 milliamp hours, so yeah, whatever. It would be optimal to make some form of machine to label these automatically for you. It would be awesome, but yeah, for now it's still just playing around. It's a little bit therapeutic. It's not what I'm bending over the camera at the moment, but yeah, normally you sit down and watch some telly and barcode up a couple of hundred. It doesn't really matter, you don't notice your time going away. Alright, we're done with that little batch. Got plenty more to do, but just for demonstration purposes, so I'll take you to my next step on the computer and I'll enter them into my database. I've got 2 ways of doing that, and I'll take you onto the computer. Okay guys, so this is how I add my batteries to my database. I have 2 methods how to do it, and I'll show you the first one, which is so I go to my battery portal, which is here. I've signed in. All the menus up here. I've got single add, and I've got new battery. So I go new battery and I search for battery type. So these ones are the Sanyo 16650 ZT. So I'll just search for 16650 ZT. I'll go on search. Now I've got 2 here, and here it is. It's this one here, ZT. Now it will show you the picture, which is pretty well the same battery. Green tab, orange body. So my barcode scanner, which works in the other one, in my charger as well. I use the same one. It's just USB, basically emulates a keyboard. So scan it in. Yep, and it automatically adds that one. And it still remains the same selected one. So I'll just put this in here. There we go. Another one. Another one. Another one. And these effectively just adding it to my database. And there's also another method. I've got a CSV import. So, alright, sorry about that, guys. Had a mate come around and had a couple of beersies. So yeah, so CSV import. So basically, just open up a notepad file and scan them in. So here we go. Watch this. One. Right, and we're done. Pick that one up. There we go. So, here we go. Grab the keyboard. There we go. We'll save that. There we go. And then we're going to save it to a file. On desktop. Make it easy. ZT. There we go. Right. So, close that off. We go bulk add. This one. Add new. Battery type would be keyboard at the end. There we go. ZT. There we go, that one there. That's the one. We'll choose a file. Go desktop. There's all our batteries that we just scanned in. And go add new battery. And this one already exists. There we go. Now, we're ready to start testing these batteries on my Arduino charger, Discharger. So we'll get back to that once we're done. Alright, so this is my charger setup. It's a bit of a mess. I'm just trying to get two cameras on here. Got the phones on the screen. Just adjust that a bit. Right in the middle. Got my webcam on the front. Alright, so these are the batteries that I barcoded and put into the database. So the charger will know what to post, what data in database and what battery ID they are. So we go, you put the first one in. And on the screen you can see it says battery 1 detected. So now it's prompting for a barcode to be scanned. I'll plug the barcode scanner in. Okay. And I'll scan it. Now it's saying it's charging. These ones got pretty good charge on them. So let's put the rest in now. Notice I've got the fan running just to cool it all down. It gets quite hot because the MOSFETs, actually all the 10 watt resistors are underneath it. On the heatsink they still get really hot and it gets the board hot. So I'm putting the rest of the batteries in. Okay, I just left all in but the last one. Scan 2, now scan 3, 4, 5, 6, 7. Right, now this is going through the menu. I can actually scan through the menu and it will stay on that screen for 60 seconds and it counts down. That one's resting, that's the barcode we scanned, that's the temperature, 18 degrees, it's 4.7, 4.6 volts, around there. Check the next one, that's resting as well. So each one's got a temperature sensor under each battery. This module here, this TP4056 is charging a bit too high, so I'll need to replace that one. This one's resting, that one's resting, that one's charging, 4.21, that's okay. Right, there's nothing in 8. Now let's put a battery back to front. Now it's drop voltage and the TP4056 is going on, but it's not putting anything into it, which is good. So we'll take that one out. Didn't fry our circuit, which is good. Put it in the right way, which goes 4.1. Now we're scanning the barcode for the last one. That one's charged, that one's going. So, you can also change this one. You can hold the button down and it'll lock the screen for you, so it'll stay on that screen until you press the button again and it unlocks it, goes back. So each screen has 2 modules and it stays on for 4 seconds on each one. It refreshes it once every second with the, so let's watch one discharging. So it'll stay here for 57 seconds, for 1 minute, sorry. So it's discharging at 1.02 amps, 3.48 volts, and it's got the time, discharge time, the current temperature, and the milliamp hours. So let's just run. I'll let this run for a bit longer. Here we go. Okay, now it's going back to the rolling screen, which just cycles through them all. Okay, I'll explain a little bit. So he's got the normal single holders. Under here we got a N-channel MOSFET under here, and that's for the polarity protection. Under here we got a charge MOSFET, and on the other side of the board you got a discharge MOSFET. Got a TP4056, which I've soldered one of the pins to the digital pins on the Arduino, and that reads the state of the LED, or the output of the TP4056 chip. This here is a USB converter, and here is a W5500 Ethernet module. Here's a robot DYN mini mega Arduino, just a standard rotary encoder. It's a 20 character by 4 LCD screen, and then it's got a serial converter, and that's pretty well it. It's not really that much more to it. Underneath, under here, there's a there's room for a SD card to be put in, but there's an issue in my design under here. The headers is 1.127 millimeters left, so I need to fix that up. And there's a couple of little iterations. I've got the power back to front here, so I just soldered. This is the 5 volts. This is 9 volts coming in, which should be about 7 volts with the voltage regulator, and that is quite crucial because you need the voltage regulator to sustain a constant voltage. Where if I run the whole circuit off the 5 amp power supply, it'll drop voltage and increase voltage depending on charges and how much load it's got, so you don't get a good accurate voltage reading on the things. So you need to isolate, you need a sustained constant voltage to get a good voltage reading, an accurate one. And on the side here, this is this top here is the 5 volt 10 amp. It's a copper plane at the top. The whole bottom is a negative plane, and the top here is a 5 volt output from the Arduino. And here is, you won't see it, but there's space for another Dallas temperature sensor. So I might in future have that as the ambient temperature, and all these just read the battery temperatures. But at the moment it just reads the initial temperature from each sensor, and it compares if the cutoff is if it's 10 degrees Celsius above the initial reading, it'll consider it hot and mark it as faulty. There's a lot more code and a lot more iterations of the circuit, but it's definitely a working prototype. I'll need to add some form of fan in to cool it down, like where I'm just running an external PC power supply style fan there. I'm running a 12 volt fan at 5 volts, so it's just nice, slow, not too noisy. Alright, so now we can see our first faulty battery. This one's only got 42 milliamps on module 2. Good old trusty teaspoon, pull it out. So that's 42 milliamps. Get a pen and write on it. Alright. Let's put another battery into that one. Okay, another one, number 8. Alright, let's check that. 35. I think we might just pull out. The one that's still charging. It's getting too high. So that charged up to 4.19, which is not too bad. Looks like number 2 is going to be faulty as well. Looks like number 2 is recovering voltage is going back up. Alright guys, I might just leave it here, and then next stage is just recharge if they're not faulty, obviously, and then after that's the finished stage, and once it gets removed then it goes back to the start again. So it's just like, as you saw with the faulty ones, it did the exact same thing, but it just says it's not faulty. It was not faulty. Cheers, thanks for watching.